So we left off with the question of whether this fit our sniff test. Now it's important to note that yes, here we're talking about the level of GDP, not the growth rate in GDP. And a higher level of GDP being in line with a higher level, with a higher investment rate fits our model. It does fit our model. It passes our sniff test. So is this a perfect fit? No, but some of you may remember from some other classes that we can put a fitted line in here, and that will be a line that minimizes the sum squared residuals, or the amount vertical distance to which we fail, or vertical distance to our observations are from our line. So that's a side note. But yes, this does pass our sniff test. But remember here, it's key, just like understanding the difference between a stock variable and a flow variable, this is analogous to that. The level is not the same thing as the rate. So now let's look at, here's Solow growth over 100 years. And now I'm going to increase the savings rate. Now watch for it. Let's see what, you see the difference? Solow growth, 100 years with a higher level of savings. It's easier to see when you go back. Let me just skip back here and watch for the difference. See the difference? Yeah, there's no difference. Again, the level of output will be different, but the growth rate will not be. Now that's comparing two countries that we start out at the same point, but with different, only thing being different in savings rates, and we keep that savings rate different across the time period. However, if the savings rate changes across the time period, then we have time and output again, time on the horizontal and output on the vertical. And again, if you want to play with this, you can absolutely set this up in Excel and play with it. But the blue line here is when across this time period I exogenously tweaked and changed the savings rates from 30% to 40% to 50%. Whereas the black line is a decreasing savings rate. Now again, we're assuming that all savings is making it into investment, and so our savings and investment rates would be the same here. So our blue line starts to look like the historical record. It starts to get us a little bit like that hockey stick. Of course, there's a problem with that. There's an upper bound limit. What's the highest that the rate of savings could be? In this case, the highest the rate of savings could be would be 100%, where we were saving the entirety of output. So that creates two problems. Across the last 200 years, we would have in effect had to dramatically ramp up the savings rate. There's a big difference going from 30% to 50%. Think about saving 30% of your income versus saving 50% of your income. It's going to have a big impact on your daily life and your consumption. So we could start to get this to look like the historical record, but only by dramatically tweaking the savings rate. And eventually we run up against the upper limit, which would be 100%. So that's one reason why this can't get us to looking like the historical record. The other reason is simply that savings rates across time are relatively stable. They tend to be driven by other factors, and we're going to talk about savings rates once we get to the next chapter on the market for loanable funds and start talking about what determines savings rates. But we actually already know the answer to that. What determines the savings rate? Well, hopefully you can think back to our big picture model of output. In other words, institutions determine people's incentives to invest in and use effectively the factors of production. So what determines savings rates? Almost certainly what's going to determine savings rates, or at least what's going to determine the extent to which savings gets turned into investment, is going to, again, be our institutions. So let me put this in terms of growth rates across time. So here again, I'm going to put percent change in output rather than output. And we have time on the horizontal, and the red line is the long-term growth rate of the United States. So if you'll notice, going from 30 to 40 to 50%, our blue line, we still are nowhere near maintaining our long-term growth rate in output. With our black line, it's even worse, but neither of them get us anywhere near our stable long-term red line. So we're going to have to look somewhere else. But before we do that, let's look at conditional convergence. So we're going to look at OECD countries, countries that are part of the Organization for Economic Cooperation and Development. And on the horizontal axis, we're going to have their real GDP in 1960. And on the vertical axis, we're going to have their growth rate between 1960 and 2000. So given what we've covered so far with our Solow model, I want you to stop for a moment and think about what this relationship should look like if our model is right. We have how rich a country, in effect, how rich a country was in 1960. Of course, this isn't really analogous to wealth, it's analogous to income. But countries that were more productive in 1960 are going to be further to the right there. Countries that are less productive will be further to the left. And then we have the growth rate from 1960 to 2000 there on the vertical. So take a moment, maybe commit yourself, maybe sit down and draw a line here. Does this look like supply, demand? Is it horizontal? Is it vertical? Based on what you have taken away from the Solow model at this point. So I'll stop this here and we'll come back and pick this up after you've maybe committed yourself and thought about this, and we will move forward.